let's do this. Okay, so first thing first, we're going to demo the actual project or application, and then we're going to move on to a little bit of a theory and how everything works, and then from there we will we'll explain the code a little bit more. So first thing first, we're in our debug folder already built for the application. We got our AES test folder, and we got our RSA test folder. Now, the purpose of this project is to demonstrate how we can use struct instructions in Rust or Rust native. In addition to that, though, we're going to go over encryption, using encryption within Rust, and how it can be applied to creating ransomware or malware. So first thing first, let's run our RSA test. So we're using CLI input or argument input from the actual compiled application, and we just ran the encryption on RSA test, the folder within our directory here, and as you can see, everything in the file is gibberish. Within our AES one, we have hello AES. Within our RSA one, we have hello RSA. So we're just going to create another document here. Test.txt. Let's open it up. Hello RSA. Let's save it. I'll verify again. And now let's run our test one more time on that directory. And then we will run it on our AES one as well. So we got hello AES. Let's run that encryption for the symmetric encryption algorithm, and there we go. It worked. Just gonna scroll up here for now. So within this project, we actually created a little bit of module here. So encryptor.rs as well as our name. So this application encrypts all files in a specific directory using two types of encryption. We have our AES encryption standard, or advanced encryption standard, and our RSA, Rivest Shamir Alderman. By implementing both encryption methods, we're actually able to showcase both types of encryption and how it works with safety and efficiency. So just a little bit more about AES encryption and RSA encryption. So encryption in Rust. We've got our AES, which is a symmetric encryption method, meaning the same key is used for both encryption and decryption. It's fast and suitable for encrypting large volumes of data. Our RSA is an asymmetric encryption algorithm that uses pairs of keys, public and private. It's often used to securely exchange encryption keys rather than encrypt large data due to its slower performance. So within Rust, we have strong libraries for encryption, allowing you to build your secure and performant applications. So the libraries we're actually using are the AES library, our RSA library, our RAND library, and our cloud. And we are using the latest versions of all of them. Here's a little overview of what structs are. So we've got some structs and we've got some implementations here. So public struct, AES encryptor, public trait, our implementations, public struct, RSA encryptor, implementation RSA encryptor, and implementation encryptor for RSA encryptor. So what are structs? Structs are custom data types that package related data together. They're like blueprints for objects. In our application, we have our AES encryptor struct, which encapsulates the AES encryption logic. We have our RSA encryptor struct that does the same for our RSA. Both structs include methods, new and encrypt file, that perform specific tasks, showcasing encapsulation and abstraction. The key features here are encapsulation, so structs allow you to group and hide internal workings, providing clean interfaces for usage. Method implementation. Rust allows you to define specific behaviors for your structs, enhancing functionality. Our traits here, so Rust's trait system allows structs to share common interfaces, enabling polymorphism, as seen within the encryptor trait in our example. So while encryption is critical or crucial for protecting data, it can also be misused in ransomware, where an attacker encrypts a victim's files and demands payment for their decryption. So the use case in ransomware would be encryption. Files are encrypted without the user's consent. Our decryption key only provided upon payment. The evolution here would be simple attacks, so initially focused on single file or small data sets. The advanced capabilities, so within modern ransomware can spread across systems, encrypting large volumes of data very, very quickly. So we can actually enhance the organization of the code by using structs in ransomware. So it can be used to organize encryption logic efficiently, making the code modular and maintainable. So you can continuously advance your ransomware by using this. The abstraction simplifies the complex behavior management, such as handling different encryption techniques. And for security, the Rust safeties guarantees to reduce common vulnerabilities, though it'll also simplify the development of potentially harmful software, aka our actual ransomware here. So some of the ethics about it. It's important for you guys to understand how you would use this in ransomware, how other or more malicious actors would actually use it. You can also use these techniques to protect against malicious actors by making faster and more secure encryption software. So let's just go over the code a little bit here. Let's start from the top. I already went over our crates. So not really important, but here we're so I'm not gonna reiterate on that, but we are importing the AES crates and libraries. We've got our cipher, generic array, block, encrypt, and key in it, as well as AES 128. We're also importing our RSA related modules, and then we're importing the randomness generator. And then we need some standard libraries here for handling the files and input-output operations. We are implementing a trait here, so we define a trait for encryptors requiring a method to encrypt files. We have our struct for encryptor with a fixed size key array. We have our implementation here for AES encryptor. And then we have another implementation here for implement encryptor for AES encryptor. We're going to open the files within the directory, apply some padding, create an AES cipher, encrypt each 16-byte block of the file, and then we're going to write the encrypted data back to the file. We have a function here to apply our PKCS padding to the actual data. If we don't pad, we're going to end up with errors, because either there's not enough or there's too much data for those blocks, and we need to pad it in order to make sure that we can actually complete the encryption. We have our struct for RSA encryptor with public and private keys. We have our constructor for the RSA encryptor to generate the keys. And we have our implementation to implement the encryptor trait for our RSA encryption. We're opening up the specific file, encrypting the file using public key NPKCS1B15 padding, and then we're going to write the encrypted data back to the file. We've already gone over our cargo, so not going to do it again. We're also implementing our command line argument parsing library, create, and modules. We're importing the AES and RSA encryptors and the encryptor trait, as well as we're saying, hey, we have a module here for it. We're going to configure our command line interface, so that's this entire chunk here is for our CLI. Encrypt our directories with AES. Put your name in here. That we have to have an argument for the directory we're encrypting, and then the encryption algorithm that we're going to use. We then extract those arguments for our directory and for the encryption key. We're then going to match, and we're going to call the specific implementations based off of that, and we're going to process the directory. So if we got AES, we need to make sure our encryptor is AES. We're using RSA, we got to make sure our encryptor is RSA. If we don't specify, it errors out. So then we got to process the directory, encrypting each file. And that's what we're doing here in the sequence. Okay, so here's our file encryption flowchart here. We start, we parse the arguments for the command line interface. As demonstrated in the code, we check the encryption type. It's AES encryption. Well, it's AES encryption. Initialize the AES encryptor, process the directory, read the directory for each file, encrypt with AES, read the file, encrypt the contents, write the encrypted data back, and then we're done. If we're starting here, when we're passing the arguments for RSA, we're going to check the encryption type, verify it's RSA, initialize the RSA, process the directory, read the directory for each file, and then encrypt the file with RSA, read the file, encrypt the contents with RSA, write the encrypted data, end. If it's an unknown type or we're arrowing out, it just ends. So here we are in our main with them both side to side. So we start up the program, we parse our arguments. So let me just adjust this a little bit further. There we go. So we parse our arguments, we're checking for directories and encryption algorithms. We're going to extract the argument values, that's within our parse here. Check our encryption type, that would be right here. We're going to match them, so that's still in this area here. If we've got AES, we're going to be using AES. If we've got RSA, we're going to be using RSA. That's all actually going to jump over to our implementations here. So if it's AES, we're going to be following the AES train. If it's RSA, it's the RSA section. Then we process everything through the directories. Should be here. Process the directory. That's going through our entire path here for encryption. Encryptor.encrypt file. So it's either this implementation or this implementation, depending on the algorithm. And then we go all the way through. That's it for our encryption program. And just remember, if you're struggling with your code, always start with a visualization of what you want to do. You can always update your visualization or your flowchart and don't forget to check your crates and the crate documentation for the latest. I created a very similar application to this one about a year ago, and I had to actually change a lot of the code in order for it to work with